Hi, I'm Parmin Sadiq, and I'm the undergraduate science correspondent for ISSCR 2026. And I'm so excited to bring you along for the meeting this year. We are currently officially in Montreal now, and I'm just about to go pick up my badge so we can avoid the rush tomorrow. But our journey actually starts back in Toronto. So, while past Parmin makes the 5-hour train ride to Montreal, let me tell you a bit more about this meeting and this video. The annual ISSCR meeting brings together, in the words of the ISSCR 2026 website, innovators in stem cell research from diverse regions and fields. It's the biggest event for those in the stem cell field each year, and this year I'll be attending ISSCR 2026 in Montreal, Canada, and bringing you along for the ride. As for what we'll do in this video, I'll take you along day by day and have these 3 goals. Number 1, to make you feel like you attended the meeting with me and capture the atmosphere from days 1 through 4. Number 2, share some general lessons from attending the meeting. And number 3, tell you about some of the exciting science at the meeting, including through interviews with scientists who were there. Now back to past Parmin, who's made it to Montreal. It's a couple hours later and we officially have our badge, so all set to go for day 1 tomorrow, which I'm so excited about. We have so many exciting sessions, including of course the plenary 1 session, the presidential symposium, where we're going to get to hear from giants of the field like Shinya Yamanaka and Madeline Lancaster. We have lots of cool focus sessions, including one on regenerative medicine in low Earth orbit, which I'm really excited about. We have some cool meetup hubs, of course, some of our poster sessions, and we even have a live recording of the Stem Cell podcast to look forward to. So absolutely cannot wait, and I'll see you tomorrow. Good morning. It's officially day 1 of ISSCR 2026, and I'm very excited to be bringing you along with me. Yesterday we did, of course, our badge check-in, and then also a little bit of sightseeing. I went to the Bell Center where the Montreal Canadiens play. I'll have Parmin, who's editing, insert some clips here. But yeah, today is absolutely packed, as I mentioned last night, and I'll see you once we get to the convention center. All right, so we just had our first session for ISSCR 2026, and it was amazing as expected. It was super exciting to see collaborations potentially even already coming to fruition through questions and through scientists from similar fields coming together, and also really exciting to see people getting challenged on their ideas and then also being able to answer questions and also explore new ideas that are suggested by other people. So that wraps up plenary 1. As I mentioned yesterday, we got to hear from some real giants in the field, and it's so exciting as someone who's been reading a lot of this work. For instance, Madeline Lancaster was presenting, and as she was talking about her 2013 paper that really set forth the field of cerebral organoids, I was just sitting there thinking, wow, I had to review that paper for a journal club in class. So it's really amazing, surreal to see people like this to be giving these talks and getting to hear them. And another thing that's really awesome about plenaries that I'm sure everyone watching this knows is how it's more than just a scientific talk, which of course is very exciting, but you get to hear those anecdotes, the little bits about people's scientific careers and how it's melded into their lives and how their colleagues have become close friends. So that's just a really amazing piece, as well as a historical piece that's usually woven through a lot of these talks.
Arun Sharma. I'm an associate professor at Cedars-Sinai Medical Center in Los Angeles and the director of our new Center for Space Medicine Research in LA. To put it simply, we want to figure out how we can harness low gravity to potentially make unique stem cell-based products in space that we may not be able to on the ground. The most common thing people know about space is that people float around. Things float around, astronauts float around, right? And we have an understanding of what happens to the human body at the macro level in this microgravity setting. Of course, astronauts have been going up to space for about 50 plus years, and we know that there's cardiovascular deconditioning, bone loss, muscle loss, immunological changes, and so on. But there's less of an understanding of what happens to the cells of the human body, including what happens to stem cells. And so we want to, on one side of the coin, we want to harness low gravity, again, to make stem cell products in unique ways, because Space, in essence, is what we call a natural suspension bioreactor. So things float around organically. There's no shear stress like what's associated with terrestrial bioreactors. So it could be a more organic way, a more permissive way to grow organoids and stem cells. On the other side of the coin, we want to understand, the extended effects of microgravity on human biology.
So many exciting things happened since we last talked. So the first thing was I went to a focus session on stem cells in space, just genuinely so futuristic. Think about some of the most futuristic words you can put together. You got stem cell biology, of course, and then space and biology in space. So cool. After that, we had a lot of cool stuff going on in the exhibit hall, including some poster sessions, amazing posters. I love chatting with new poster presenters. I also went to a meetup hub for science communication, of course. And then finally, we had a live recording of the Stem Cell podcast, which is, as a longtime fan, that was very, very exciting for me. But anyways, packed day. I feel like my head is exploding with knowledge. So I will see you tomorrow for day 2. Well, we haven't chatted in a while because I was slightly late this morning, but we're about halfway through the day now. We had some more amazing science spotlight sessions, of course, our plenary. So just wanted to share a couple of takeaways again. So the spotlight session I attended this morning was on clinical trials. So yesterday was really focused on a lot of basic science, some translational stuff as well, but this was just really, really cool to get to see all these translational applications of the work that's going on, and to see a lot of different approaches to seemingly similar problems coming at it from a lot of different angles. One more general takeaway is just the importance of conferences and events like this in contributing to the development of scientists, which sounds obvious, but a lot of it is more implicit skills that we don't necessarily think about as often with science. Things like speaking really well to different types of audiences, and it's really a skill that you learn through practicing, of course, but also through watching, which is something that you get through events like this. All right, I'm heading over to some of the one of the focus sessions now, and I'll update you again soon.
Misra. I'm a clinician scientist currently at the McGill University Health Center. On the clinical side, I'm a transplant nephrologist. I treat patients that have kidney disease and we give them kidneys to restore function. And on the research side, I'm a stem cell biologist. When patients' kidneys fail, the best therapy for them is to get a kidney transplant. So this typically involves getting a kidney for the most part from a deceased donor. But there are two big issues with kidney transplantations. The first is that there are not enough kidneys to go around for every patient that needs them. So stem cells provide one solution to that problem, because you can actually generate organs on demand for patients that need them. So you don't have to wait then for a patient to pass away, unfortunately, to get a kidney. But the second big problem with transplantation is that patients after transplant need to take medications that suppress their immune system so that their body doesn't reject the organ. This is a problem because those medications have a lot of side effects, like infections, of course, and even cancers. And so stem cells, again, have another kind of leg up here over deceased donors, in that we can actually now make stem cells from people. And so then we can potentially generate kidneys for them that would be their own, so the immune system wouldn't reject them.
All right, and that is a wrap on day 2. Since I last updated you, we had lots more exciting things happen. So first, I went to a focus session on tissue and organoid engineering, and the organoid field just never ceases to amaze, keeps on pushing the frontier. So many interesting diseases being modeled and new approaches being found. Then there was a meetup hub for policy and ethics, and then finally went to the all attendee reception, and I'll put in some videos here, but that was pretty cool, very fun way to end the night. And that is a wrap on days 1 and 2, and I'll see you tomorrow for day 3. All right, welcome to day 3 of the conference. We're actually almost done with the day, but just thought I'd give you a quick recap. So, started off with an amazing spotlight session as always. The one I went to for today was on engineering sulfate. Then we had plenary 3, which was also great. A lot of cool developmental stuff. I'll just leave you with one fun fact for now, which is that female intestines actually grow in length during pregnancy, at least in Drosophila and mice. The focus session I went to was on in vitro gabetogenesis, both on the science side and also on the ethics side. And so that was such a good discussion. It really combined a lot of my interests, so it was really, really cool. I'm off to one of the meetup hubs now for the meeting ambassadors, but I will update you later soon.
Isabel Farinas, and I'm full professor in cell biology at the University of Valencia in Spain. In my lab, we try to understand quiescence, which is an ancient property of cells, but we now realize that it's exhibited in multicellular adult organisms. It's exhibited by stem cells in the different tissues. So it's a property that allows them to go into a resting state that they can exit from to engage activation and produce new cells. So that's a fascinating cell process.
All right, welcome to day 4, the final day of ISSCR 2026. It has been a crazy ride so far. We're almost done the day actually because it's a shorter day today. We had our first 2 plenaries of the day and we have the final one coming up where we're going to get to see who wins the awards and hear from them, so that's very exciting. But again, as always, it's been a great day, learning so much. We had one of the plenaries on clinical applications, which was so exciting. It's always so cool to see in one meeting everything going from the basic science to how it's really being applied and changing people's lives. So yeah, that is a wrap for ISSCR 2026, almost one more session.